let's solve some questions to prepare you for your quiz 3. Now, before we start solving questions, let's just talk about some of the basics that you're supposed to know before you write your test. Okay, number 1 is that on trigonometry, okay, hope most of the questions won't cover some of these things. You're supposed to know, different types of triangles, okay, as a topic. You know that there's a right angle triangle. If I draw it like this, there's an isosceles triangle which has two sides equal, let's say this one and this one, and there's an equilateral triangle which has all the sides equal. Okay, then on trigonometry, you're supposed to know what we call special angles. They are special because of their nature. Okay, you can solve them using this type of triangles that we've just drawn. Okay, so there's a 30 degrees, there's a 40 degrees, 45 degrees, there's also a 60 degrees. Okay, then what other thing are you supposed to know? You're supposed to know what we call identities. Okay, so the Pythagorean identity, you are not supposed to forget it. Sine squared x plus cos squared x is equals to 1. This is very important because that's where all the other identities are going to come from. Identities like tan squared x is equals to sec squared x minus 1. Identities like cot squared x is equals to cosec squared x minus 1, and other identities, and some of the things like double angles like let's say a plus b. You know that this is just sine a. You're going to have sine a cos b, plus you're going to have now sine b cos a. And for cos, you're going to, if you have cos a plus b, what are you going to have? You're going to have cos a cos b, then the symbol changes, becomes minus, then you have sine a, then sine b. So those are some of the important things that you're supposed to understand on identities. Double angles, okay, can stretch as far as also the double angle for sine, the double angle for cos. Things like if we've got sine 2a, what is sine 2a? Sine 2a, you know that this is just the same as 2 sine a cos a, very, very important. Then if you've got cos 2a, now for cos there are 3. Here I'm just going to write the one where the other 2 comes from. Okay, cos squared a minus sine squared a. How do they come about? Because you can replace the cos squared a and the sine squared a based on the Pythagorean identity here. Okay, so these are some of the things that you're supposed to know. Very, very, very important. Then you also have to know how to solve equations. Very, very important on this topic. So solving equations. Now equations, you know that your pi, in terms of pi, you know that it just equals to 180. You're not supposed to forget this conversion factor. Then lastly, you have to know how to sketch. Then you are good to go. So let's solve some questions. So the first question is, find the exact value of each of the following. Okay, so A, we are finding cos 240 degrees. Okay, so how are we going to solve this one? So you know that these ones are just, you're solving them without using a calculator. Okay, so you're solving them based on what you've learned about special angles. Okay, so this 240, in which quadrant does it fall? You know that there are quadrants. Let's say this is our Cartesian plane. We say all students take coffee. Okay, so all to mean in this region all of them, they are positive. Here only sine is positive. In the third only tan is positive, and in the fourth only cos is positive. So now if you look at 240, let me just put the demarcation. This is 0 degrees, this is, let's say this is 90 degrees, this is 180 degrees, this is 270, and you're coming back to 360 here. Okay, now where is your 240 going to fall? Okay, so you know that it's going to fall in this region. Okay, if that's the region it's going to fall, therefore what are we going to do to find the angle? Remember, when you're measuring the angle, there are two conditions that you should meet. You are measuring, number one, the acute angle. Now an acute angle is less than 90. Okay, it's less than 90. Then number two, you are measuring the angle with respect to the x-axis. So these are the two conditions that should be met. So let's solve based on these two conditions. Okay, so if this angle was here and the angle that we wanted was that, let's say this is 240, let's assume, therefore the angle that you are going to get is an acute angle. You're only going to get this part because it's the one that is less than 90. Okay, so that's what we're going to do. So 240, for us to find the other angle, so we're going to subtract. We're going to say 240 minus 180, and when you do that, you're going to have a 60 degrees. Therefore this cos 240 is equivalent to cos 60. Now cos 60 degrees is just the same as, you know, 1 over 2 according to your identities. But now look at it, is in this quadrant. In this quadrant only tan is positive, so the other identities will be negative. Therefore our final answer, cos 60 now will be equals to negative 1 over 2. So that's how we solve this one. Let's solve B. Now B, we're finding tan 120 degrees. So how are we going to solve tan to 120 degrees? Okay, it's the same concept. Where is 120 going to fall? 120 is going to be in this region. Okay, so it means this is the angle that we want. But like we've said, we are measuring the acute angle, so we are going to get this angle with respect to the x-axis. So that's what we're going to do. So for us to find that angle, you know, we're just supposed to subtract from 180. So therefore what am I going to have? I'm going to have 180 degrees minus 120 degrees, and when I do that, 180 minus that is just 60. So tan 120 is equivalent to tan 60, and your tan 60 degrees is just equals to a pi over root 3. Now if it's root 3, let's look at in which quadrant is falling. So it's in this region, and in this region only sign is positive, so it means our answer is what? Is a negative. So therefore our answer is negative root 3. So that's how we solve B. Then how do we solve C? So for C, we are saying sine of 300 degrees. So how are we going to solve that one? You know, 300 falls in this region, so it means we want this angle. But like we've said, you're measuring the acute angle. So the acute angle from this is what? Is this point, this one. So it means we're going to subtract from 360. So we're going to say 360 degrees minus 300. Okay, and when we do that, you're getting a 60 degrees, and a 60 degrees. So therefore sin 60 now degrees, what is it going to be? From your special angles, you know that this is just the same as the root of 3 over 2. Now look at in which quadrant is it. You also consider the quadrant. It's in this quadrant, but now in this quadrant only cos is positive, so therefore our answer is going to be negative. Therefore the answer is negative root 3 over 2. Okay, maybe let's solve the last question on this one. Let's solve D. D, we have cos 210, cos 210. So we're going to find cos 210. It's the same principle. Where is 210 going to fall? It's going to be in that region. So this is the angle that you want, but you're measuring an angle with respect to the what? To the x-axis, and it should be an acute angle. So therefore you're going just to get this acute angle. So let's do that. So we're going to subtract from 180 from that. So 210 minus 180 80 degrees. And when we do that, what do we get? We're getting like a 30. Okay, now cos 30 degrees, you know that this is just the same as the root of 3 over 2. Okay, now look at in which quadrant is it as well. You have to also consider that. Okay, 210 we're saying it's in this quadrant, and this angle is also in this quadrant. So what in this quadrant only tan is positive, so it means our answer will be a negative. So negative root 3 over 2, that will be our final answer. So let's solve the next question. Use compound angle identities to find the exact value of those equations. So let's start with the first one. So we are given sine 15. So how can we make a sine 15 based on the special angles that we've talked about? Okay, so sine 15 can also just be written as you can say this is just the same as if I subtract 45 minus 30, that will give me a 15, and we're using compound angle identities. Okay, so we're going to operate based on that. Okay, so now you remember that your sine a plus, let's say, a minus b, you know that this is just equals to sine a cos b minus, okay, cos a sine b. Okay, so that's how you solve this one. But now what do we have? We've got 45 and 30. So the data that we have, we've got sine 30, so it means we're going to be finding something like sine 30, or let's say sine 45. We're going to be finding cos 45. We're going to be finding cos 30. We're going to be finding sine 30. So let's find these ones. We know, so that we just replace in the equation when we start solving. So sine 45, you know that it's just the same as 1 over root 2. Cos 45, they are the same as well. It's 1 over root 2. Sine 30, cos 30, you know that cos 30 is just root 3 over 2. Then sine 30 is just 1 over 2. Now the ones on top, 1 over root 2, and the cos 45 is also 1 over root 2. At least I will not leave a root down, so I'm going to multiply by root 2 on both sides. So I'm going to multiply by root 2 both down and on the numerator, because I don't want to have a root down. So I have root 2 over root 2 multiplied by root 2 down, that will just give me a 2. Okay, same with the one for cos 45 as well. It's going to be root 2 over 2. Why? Because never leave a third down. That's what we know. Okay, so if that's what we have, we're just going to replace in our equation. So in our equation, we've got sine a. Okay, sine a, we're saying it is 1 over 2. Okay, sine a, we're saying it is what? It's 45. Okay, not that. It's this one that we're just from finding. Okay, so we're just going to replace indefinitely. So what do we have? What we have, we've got root 2 over 2. This is multiplying by cos b. Cos b, what is cos b? Cos b is root 3 over 2. Then there is a minus. We come to cos a. Cos a still that. Okay, root 2 over 2. Then sine b, that is just 30. So we have 1 over 2. Then we solve. 2 multiplied by 2 down. This, so that gives us 2. Root 2 multiplied by root 3, you know that just gives us root 6. Minus, then this side we've got 2 multiplied by root 2 multiplied by 1, that is just a root 2 over 2 multiplied by 2 down, that is just a 4. Okay, this one is also a 4. Apologies for that. Then what are you going to have? 4 is a common denominator. Then root 6 multiplied by root 6 minus root 2. So this will be the final answer for the first one. Let's solve for the second one. So we are solving cos 15 degrees. Okay, not much different from what we're just from solving. So this is the same as 45 minus 30 degrees, and we're going to do the same. We're going to find what cos 45 is, what cos 30 is, what sin 45 is, what sin 30 is. Okay, so what is cos 45? Okay, we just from finding cos 45, that was just root 2 over 2. Then cos 30, it was root 3 over 2. Then sin 45 is the same as cos 45, which is root 2 over 2. Sin 30 is just the same as 1 over 2. Then how do we find the cos? You know that when you're finding cos, if it is cos, if you've got cos A minus, let's say minus B, how are you going to find that? You're going to say cos A cos B. The symbol changes, it becomes plus, then you have sin A sin B. So we're just going to replace and solve. So what do we have as our cos A? So let's take this one as A, this one as how are we going to do that? Okay, cos A, we are saying it is cos A multiplied by cos B. Cos A, this is we're saying is root 2 over 2. This is multiplying by cos B, so this is B. Then okay, yeah, like that, multiplying by, this is multiplying by cos B, which is root 3 over 2. Then we have a plus on the other side. We're multiplying sin A multiplied by sin B. So sin A, that is root 2 over 2 multiplied by 1 over 2. Then we just solve. Down 2 multiplied by 2, that is a 4. When I multiply what is on top, that is just a root 6 plus, when I come on the other side, 2 multiplied by 2 down, that is just a 4. Root 2 multiplied by a 1, that is a root 2. Now because I have the common denominator, which is just the same, I'm just going to get 1. Then I add what is on top, root 6 plus root 2. So that's how we solve, you know, this one. We are done for this one. Okay, I think let's also solve the last one. So for the last one, tan 75 degrees. So what are we going to do? Two numbers that we can either subtract or to, I think 45, when we add 45 degrees plus 30 will give us that, right? Because 5 plus 5, that is a 70, that's a 5 plus 5 plus 0 on the other end, that is a 5. Then 4 plus 3, that is a 7. We're having our 75. Okay, so we can use that. Now you know that for tan, if I've got tan A plus B, tan A plus B, it will just be tan A. Okay, allow me to use a capital letter, tan A plus tan B over 1 minus tan A tan B. Okay, so this is like the identity. Now what is tan 45, what is tan 30? That was we're supposed to find. So let's find the tan 45 and tan 30 degrees. Okay, so tan 45, you know that this is just a 1. Okay, tan 30, this is just 1 over root 3. Then what we're just supposed to do is just to, you know, substitute. Okay, so tan A, let's call this one as A, let's call this one as B. So tan A, we're saying it is 1 plus tan b is 1 over root 3 over 1 minus tan a multiplied by tan b. That is a 1 is multiplying by tan b, which is 1 over root 3. Now if I get what is on top and if I add, what am I going to get? If I've got 1 plus the root of 3, if I'm adding these ones, what am I going to get? The common denominator will be root 3. 1 multiply 1 into root 3, root 3 multiplied by 1 on top, that will just be root 3 plus root 3 divided into root 3, that is just a 1. So this is what I have, okay, on top. So on top I'm finding root 3 plus 1 over root 3. This is dividing with what is down. What is down is, instead of adding, now we are subtracting. So when I subtract that, I'm subtracting 1 minus 1 over root 3. Let me just do the same. Root 3. So into root 3, that is root 3. That is 1 minus 1. Okay. So we are dividing by root 3 minus 1 over root 3. Okay. So allow me to wrap this part. So now what do we have? So I can simplify this one as root 3 plus 1 over root 3. You know the division changes the sign, so it becomes root 3 on top over, you have root 3 plus a, or a minus 1 actually. So I have a root 3 minus a 1. Okay, that is root 3. Okay, so now what do we do? So the root 3, this one and this one can divide, they just give us a 1. Then what do I have? Now what I have, allow me to write it on the other part, on the other side. What I have, I've got root 3 plus 1 divided by root 3 minus 1. And you know that these are surds, so for me to find the other part, I just have to multiply by the conjugate on both sides. So the conjugate of the denominator, you know that it's just root 3 plus 1. Okay, so I'll do it on both sides, root 3 plus 1. Okay, so now what am I now going to have? So the one that is down, I'll just use the difference of two squares. Okay, you multiply by the conjugate, but you know that this and this one's a difference of two squares. So I can just get the first one and square it, okay, to be the difference of two squares. So now that 3 squared, it will just be a 3. Okay, the square root of 3, and there's a square, the square and the root will cancel. I'll just remain with a 3. Then 1 squared, that is just 1 squared. What is 1 squared? It is just so in this case it will be a 1 or a positive 1. Okay, then now my job is to find what is on top. What is on top? I'm multiplying this, and this is not the difference of two squares because they've got the same sign. Okay, so root 3, it will multiply by what is in the bracket first. So when I do that, root 3 multiplied by root 3, you know that I'll just have a 3, plus root 3 multiplied by the 1, I'll have root 3. Then when the 1 multiplies with everything that is in here, I'll just get everything that is in the bracket, which is plus root 3 plus 1. Okay, now what do I have? On top I've got 3 and 1, they can add, so I have a 4. Okay, plus then root 3 plus root 3, I'll have 2 root 3. Everything over okay, what do I have? Okay, so this one, if it's a difference of two squares, actually 1 squared, it will just be 1, then there is a minus, so this is a minus. So 3 minus 1, it is just a 2. Okay, then what do I now have? I can now divide 2 to simplify it further, I can divide 2 into this one, then after I do that, because that's what it means, then the 2 also divided by that. So to simplify it, therefore my final answer to be 2 plus root 3, okay, when it divides on both in both of them. So that will be our answer. So let's solve the next question. We are told to prove the following identities. So how do we prove the following? Let's start with the first one. So we have cos 2x is equals to 1 minus 2 sine squared x. So how do we solve this one? Now, earlier when we introduced just this same session, we said you have to know double angles. The double angle for cos or cos 2x, we said it is the parent one is cos squared x minus sine squared x. Okay, if we've got that one, then we've said there are other two which we didn't do in the first session. It was just introducing. So what are we going to do? What we are going to do, you know that from your parent identity, the Pythagorean identity, which we say sine squared x plus cos squared x is equals to 1. If we make cos squared the subject of the formula, we have cos squared x is equals to 1 minus sine squared x. So this is what I'm going to replace where there is cos squared x. Okay, when I replace, let's see what we have. So if I replace, I'm going to have 1 minus sine squared x. Okay, I've replaced, then there's a minus sine squared x. This is not distributing in, the negative is not distributing into that. No, it's just normal arrangement of mathematics here. So now what do we now have? You're able to see that we just have 1 minus sine squared x minus sine squared x. Then what do we have? We go to 1. Now negative sine squared x and negative sine squared x, these ones are going to add, and because there's a negative, so we have a negative 2 sine squared x. Hence proven. Okay, the left hand side is equals to the right hand side, just as we are able to see like that from this equation. Okay, so that's how we solve the first one. So proving identities is very easy as long as you know what they're talking about. Okay, so B, we're solving sine 2x is equals to 2 sine x cos x. Actually, this one we said is it's a double angle identity for sine. That's how it is. Okay, but how do they want us to prove? So maybe you can just write it as sine 2x is just the same as x plus x, right? Okay, then how do you find sine x of when there are two like that? What are you going to do? You know that this is just straightforward. You're just going to say sine x cos x plus cos x sine x if you want. Or maybe to not confuse people, let me just write it the same way, because multiplication is commutative, right? So I'm going to also write sine x cos x. Now because these two are the same, this is just the same like you're adding x plus x. X plus x just gives you 2x. Okay, so that's what we're also going to have. We're just going to have 2 sine x cos x. So this will be our final answer, and this is equals to that. So that's how you solve B. Let's solve C. So C is, we are saving cos 2x is equals to 2 cos squared x minus 1. Okay, for cos we said there are two identities. It's the same thing like we are just from solving on the other one. So we said cos 2x. The parent one, we said it is cos squared x minus sine squared x. So now in the previous one we had to separate, we had to replace the cos squared x to find the first question. But now let's try it in this other one to substitute by this one. So what are we going to have? If we make sine squared the subject of the formula from our parent identity or our Pythagorean identity, you know that it's just sine squared x is just the same as 1 minus cos squared x. If that is the answer, so where the sine x squared, we're going to replace by this. So let's do that. So what are we going to have? We're going to have cos squared x minus, now let me now replace 1 minus cos squared x, and when I solve, let me distribute the negative. When I distribute the negative 1 multiplied by 1, that is just a negative 1, which I'll write here. Then the negative multiplied by negative cos x. Okay, so what am I going to have? I'm going to have the positive cos squared x, just the way it is. Then what do I have? Now you're able to see that the cos squared x and the cos squared x, these ones are adding up, so we're just going to add them, and when you add them, you're going to have 2 cos squared x minus 1. So this will be our final answer, and look at, it's just the same as that one. So what are you going to do? This is hence proven. Okay, because your left hand side is equals to your right hand side. Okay, so that's how you are going to solve that one. Let's solve the last question on this, on proving on tan. So how are you going to prove for tan? So we're trying to prove tan 2x is equals to 2 tan x over 1 minus tan squared x. So what do we do in this case when we're doing with tan x? Now remember the two, you know that tan 2x is just the same as you can say this is the same, tan is just the same as sine over cos, right? Now because it's 2x, I'm also going to put 2x on both sides. Okay, 2x. So what is sine x? What is sine 2x and what is cos 2x? These are the double identities, and we've just talked about them. Sine 2x, we've been talking about it. We're saying this is just the same as, and they were just from solving it as an identity as well. So we say this is 2 sine x cos x. Then cos 2x, okay, we said we will get the parent identity, always at least get the one, the first one, before the other two, the one that we're just from proving. The first one, the parent one, is cos squared x minus sine squared x. So we're just going to replace with what we have here. So when I replace sine 2x with so I'm going to have 2 sine x cos x on top, divided by cos 2x. I'm going to replace with what we're just from writing there. So I'm going to have cos squared x minus sine squared x. Then what we're going to do is something that is very interesting. We're going to divide all the expression by cos squared x, and in this case you are assuming that cos squared x is not equals to 0. Why? Because if you divide by a 0, it becomes undefined. You know that, right? So what are we going to do? We're going to get our 2. Let me divide by everything by cos squared x. 2 sine x cos x, this is on top. Okay, I'm dividing by cos squared x. Then don't forget your division. Down we've got cos squared x. This is also dividing by cos squared x minus, I get my sine squared x divided by cos squared x. Okay, so allow me to rub on this part and we see what we have. Now what we have on the other side, if I divide, this is cos squared and there's a cos on top. You know that if I divide down, I'm going to remain with one cos. Okay, if I divide this divided by that down, I'm going to remain with one cos. So I'll remain with cos x. Okay, now I've got a sine x divided by cos x. This is just the same as tan. Then there's a 2 in front, so therefore on top I'm going to have 2 tan x. Okay, over, I come down, cos squared x divided by cos squared x, that just gives me a 1. Okay, now there's a minus, I'm also going to put it there, so a minus. Then I've got sine squared x divided by cos squared x. What am I going to have? Sine over cos is tan, right? Because they are squared, I'm going to say tan squared x, and that's how you're going to solve. And you're able to see that your right hand side or your left hand side is equal to your right hand side, which is that. Hence, and you are done like that, and you write, and don't forget, hence proven. Okay, so let's solve another question. Now we're taught to solve each of the following equations for that range. X is between 0 and 2 pi. 2 pi, we've said, is just the same as 360. So let's start with the first question. So A, we are solving our sine of 2x, or sine 2x minus sine x is equals to 0. Now we're just from talking about what sine 2x is. What is sine 2x? Okay, so don't be a master of your identities. Sine 2x, we said, is just the same as 2 sine x cos x. Then now we put the other one that has remained, or that is in the equation, minus sine x is equals to 0. Now from here, you're about to see we've got this part and that part, and sine x is common, so we can factorize. So if I factorize, I'm going to have sine x, then what remains in the bracket, I remain with okay, what if I get, if I factorize, what am I going to get? I'm going to remain here, I'm going to remain with a 2 cos x minus a 1 is equals to 0. And you know what this means? It means that sine x is equals to 0, and this whole expression in the bracket is also equals to 0. So let's just solve that. So let's start with sine x. We're saying sine x is equals to 0, and the other one we're saying 2 cos x minus 1 is equals to 0. Let's start with the one for sine x. Sine x is equals to 0. Where else is sine equals to 0? If you're going to go on your diagram, where else is sine x equals to 0? So sine x equals to 0 is also at 180. But now look at, they've given us a range in terms of pi, so it means your answers are supposed to be in pi. So we've got 0, 0, there's nothing like 0 pi, but 180 is just the same as pi, right? So we found the two solutions for sine of x. What about on the other one? Let's solve the other one, 2 cos x minus 1. So what are we going to do? You're going to have 2 cos x. When I take the negative 1 to the other side, becomes positive. Okay, then I divide by 2 on both sides. So the cos x is equals to 1 over 2. The way I'm finding x is equals to cos inverse of 1 over 2. X is equals to, where is cos 1 over 2? You know that is just is it a 60? Is it a 60? Yeah, you know that x in this case is 60 degrees. Okay, now if cos is 60 degrees, where else is cos positive? Okay, because if this is our graph, okay, all students take coffee. Now we've only found in this quadrant, and we found that it is 60 degrees. Where else is cos positive? You're able to see that even in the fourth quadrant, cos is positive. So you're going to also find in that region. So what are we going to do? We're going to subtract 360 minus a 60, and when you do that, you're just getting 300. So another answer for cos, it is 300. Now, like I've said, they want your range in terms of pi. So 60 in terms of pi, what is 60 in terms of pi? Okay, so you're just going to do your conversion factor. Like we said, it's very important to know your conversion factor. This 60, converting it to pi, it is 180 degrees, which is equivalent to pi. So you can divide and divide. 6 into 6 is 1. 6 into 18 is 3. So you have pi over 3, comma. What about 300? 300 in terms of pi, again you're going to say 180 over pi. You can cancel the zeros. Okay, what can we do to the other one? So we're going to also find again two numbers. If we say 6 into 30, that is 5. 6 into 18, that is a 3. So therefore we got 5 pi over 3. So our answers, therefore, the answers or the solutions for x, the solutions for x are x will be equals to 0, comma, which comes earlier. Okay, we can put, what do we put? From 0, we're going to say pi over 3, that is 60, right? Then you put them in order. Then pi, now that follows, pi is 180. Then the last one, which is 300, which is 5 pi over 3. So these will be the solutions for x. Okay, so that's how you're going to solve the first one. Now let's solve the other one. So the other one, we've got 2. We're solving b. So for b, we've got sine 2x is equals to cos 2x. I think I can make a tan from here. Now, don't just divide indefinitely. Okay, for this one, yes, you're able to see that we can make a tan from this one. But don't do that for everything. You have to first analyze what you have. Okay, so this can divide. On the other side, I'm going to have sine over cos, that is just the same as tan. Now we have a 2x is equals to, when you divide on the other side, just give us a 1. So that is our answer. Now we found that tan 2x is equals to 1. So what is that? Now what is 1 on your graphs, or let me say with special angles? 1 tan, where tan is equals to 1, it is a 45 degrees. So that is one of the answers. Then where else is tan positive? Okay, so look at your Cartesian plane, or students take coffee. Now tan, it is in the third quadrant, in which it is positive. Okay, it's also positive in that region. So what are we going to do in that region? You know, we're just going to subtract 180 minus 40 and minus 45. Okay, so if we do 180 minus 45, what do we have? No, actually we're supposed to, are we adding? We're supposed to add, actually. Okay, so we're supposed to add, because it's something like this, then you want this, but you want this angle. Okay, so you know that, because so we're going to add 180 plus the 45 to get in that quadrant. So when you add, that just gives me, I've got a 5, I've got a 2, I've got a 2. Okay, so I have a 225 degrees. So these are the two answers, but now we're taught to simplify them in terms of pi. So now for 5 in terms of pi is just the same as 180 over pi. Okay, now when I divide, what do I have? Okay, when I divide, what do I have? If I say 9 in here, 9 in 45, I've got what? 9 into 45. What is 9 into 45? But is it 5? Then 9 into 18, that is 9, that is 2. So I have a 20 down. Then 5 into 5 is 1, 5 into 20 is 4. So therefore I've got pi over 4 as our first answer, or 45. Then on the other side I've got 225. Well, we're also going to do the same. 180 is equivalent to pi. Then when we divide, what do we have? We can also look for two numbers that can go into both of these ones. So if we say, let's start with which one? Let's say, can 3 do that? Okay, let's first start with 3. 3 into 21, that is like 7. Remainder 1. Then 3 into 15, that is like a 5. Then when I come to 3 into here, it's 6. Then a 0. Is it? Yes. Then anything that we can also divide to, let's say 3 again into this one, it is like a 20. Then 3 into 7, that is like a 2. 2 into 15, like a 25. Okay, so now we can do 5. When 5 goes into 25, that is a 5. Then when 5 goes into a 20, that is a 4. So therefore this one converts to 5 pi over 4. So these are the two answers in terms of radians. Okay, now what do I now have? I've got that. So we had 45. So this is the first revolution. Now we also have another revolution. Okay, we have another revolution because 2x, what 2x means is that this is your 45. This is 45. You've taken one revolution, yes, and you found these two answers. But now it's 2x. It's 2x here. So it means you have to take another revolution. If it was 3x, so 2x, since it's 2x, we're going to take another revolution. And the full revolution is what? 360. But if we had 3x, we are going to take another one. Okay, and we're going to have 6 answers if it was 3. But now since it's only 2 revolutions, we're supposed to have 4 answers. So to these 2 answers that we have to add 360 to each. Now we had the 45, which is pi over 4. So let's add 360. And we had the 225. So we're also supposed to add a 360. Okay, 45 plus 360, something like 405. 225 plus 360, something like 5, let's say 85. Okay, okay, so I've used the calculator just to be fast on that one. So now we've got these two answers. We've got 45, 405. So we also have to convert it into pi. Okay, in terms of radians. So what am I going to have when I do that? Okay, so what do we have? So which number can go into both? So 180. Okay, to give us like, so let me just use a calculator first. So this is 9 pi over 4. Okay, 9 pi over 4. Is it? Let's see. It's giving me 9 pi over 4. Then the other one is we have 585. This is pi over 180. It's giving me 13 pi over 4. Okay, if these are our answers, okay, if these are our answers, so if these are our answers, what are you supposed to do? So let me just write them here. 2x is equals to pi over 4. Then we've got 5 pi over 4. Then we had the 9 pi over 4. Then we had 13 pi over 4. So if these are our answers, what do we now do? We're now going to find the value of x. To find the value of x, it means we're going to divide throughout by 2. But how are we going to do? We can say just multiply by half throughout. Okay, on the other side, because we just want x, so the 2 and the 2 can divide. This side I'm going to remain with x. So then now we're able to see that the 2 multiplies with everything that is on the denominator, which even makes it simple. So what are you going to have? So on top I'm just going to have pi over, when I multiply by 4 through, we've got 4's throughout, and we multiply by 2, that will just be giving us 8. So this will be pi over 8, this will be 5 pi over 8, this will be 9 pi over 8, the other one will be 13 pi over 8 as well. So these are the solutions that you are going to have. Okay, so sketch the graph of the following trigonometric function. In each case, state the period, the amplitude, and the vertical shift. So this will be the last question. So let's start with the first one. So we are saying y is equals to 3 sine of x. Now we are taught to find the amplitude, which is how high the graph is going to go. We are taught to find the period, which is the time it takes to complete one full revolution. We are taught to find the vertical shift. Now the vertical shift is just the shift in the y direction. Okay, so what do we now have? So we're just going to solve a and b. So amplitude, in this case you're able to see that the coefficient there is just 3, so we're finding the absolute value of 3. The absolute value of 3 is just a 3. Then the period, you know that the period is just equals to 2 pi over the absolute value of b. Why I'm putting absolute value of b is because we don't want our time to be negative, okay? Because time is not negative, okay? Can't say negative 2 seconds. It doesn't make sense. Okay, then the vertical shift, don't have a shift in any y direction. A shift would be like, it would have been something like, let me say 5 here. It means we've shifted our graph. Instead of it being at 0, 0, now we've shifted it to maybe, let me say 5 units up, okay, and 5 units down. So that's what it means. But we don't have that, so we're going to we have a shift of 0. Okay, the vertical shift is 0. So vertical shift is 0. What about the period? So I've got 2 pi. The coefficient of b is the coefficient of x. Now the coefficient of x in this case we're able to say 1. So therefore our period will just be 2 pi. So we have everything that we need to graph our function. So let's say this is our x-axis, this is our y-axis, this is our x-axis. Okay, so what are we going to have? So our amplitude is 3. So the graph will be rotating between 3 and negative 3. Now we've got 2 pi, the time it takes to complete a full revolution. A full revolution is 2 pi, and they've given us, or it's 360. Now the half of 2 pi, allow me to divide my graph into 4 parts. Now 2 pi, the half of that is just pi. The half of pi is just pi over 2. Then for me to find this region, I'm going to multiply the first one with 3. I'm going to multiply this by 3. So I have 3 pi over 2. Or if you want, you can add pi plus 2 pi, then you divide by 2, okay, to find this, okay. But I prefer the latter. So now what do we have? So we've got everything that we need to graph this function. Now you're able to see that this is a positive sign graph. There is no negative. So because there is no negative, it means it's going to pass through this point, pass through that point, and now it's going to go up and come down because it is positive. So how is our graph going to be? The sine graph always starts at 0, 0, okay, provided there is no shift in any direction. So we're going to do that. So that will be our graph for the first question. Now let's solve the other one. So what do we have? We've got y, b, we're saying y is equals to sine x over 2. So the amplitude in this case, it is, you know, able to see that it's 1, or the absolute value of 1, which is just a 1. Then what about the period, which is t? Period is the time, so 2 pi over the coefficient of x. Now we've got x over 2. This is just the same as 1 over 2 and x, like that. So the coefficient of x in this case is half. Okay, so that's what we're going to do. We're going to put half here. So this is dividing by half. So 2 pi divided by half, that is just the same as 2 over 1, right? Or and 2 pi multiplied by 2, that is like a 4 pi. So that is the period. Then the vertical shift, we don't have a vertical shift in any direction, so the vertical shift is just a 0. We have everything that we need to graph our nice and beautiful function. So this is our y-axis, this is our x-axis. So we are saying the amplitude, it is a 1, so this is 1 and this will be negative 1. Okay, then what do we have? Our period is 4 pi. Okay, so the half of 4 pi, that is 2 pi. Okay, the half of 2 pi, that is just pi. Now between 2 pi and 4 pi, you know that that's just a 3 pi. Or get the first one and multiply it by 3. Okay, so that is the same thing. Now if you look at the graph, it's positive. Because it's positive, it's going to pass through 2 pi and 4 pi. Now it's going to go up and it's also going to come down, and it's going to start at 0, 0 because you don't have a shift, so it's going to go like that, pass there and go like that and go like this. So that will be our graph, okay, for that. So let's solve one on cos. Let's solve one on cos. Okay, the last one actually now. So we've got c. Our c is equals to, we're saying y is equals to cos 3x. Okay, cos 3x. So our amplitude, what will be our amplitude? Now our amplitude, you're able to see it's a 1, so it's just a 1. Our period, it's 2 pi over b, or divided by b. B is a coefficient of x. Now what is the coefficient of x in that case? It is 3. So what are we going to have? We are going to have 2 pi divided by 3. So that will be our period. We don't have a shift anywhere. Vertical shift is 0. So now what do we have? We're going to say this is our y-axis, this is our x-axis. Okay, so now what do we do? Amplitude is 1. Okay, like that. Then we've got a period of 2 pi. So 2 pi over 3. Now the half of this is going to give us 2 pi over, is it 6? Yes. Then the half between that and that, what am I going to have? I'm going to have 2 pi over 12, but I can simplify this one. 2 into 2 is 1, 2 into 12, that is a 6. So I have a pi, over 6. I have a pi over 6. Then I can multiply this by 3 to get 3 pi over 6. But again, I can simplify this one. 3 into 3 is 1. 3 into 6, that is a 2. So I can have a pi over, is it a pi over 2? Yes, now I've got everything that we need. If you look at the cosine graph, it's positive. So because it's positive, you know that the cosine graph, the way it behaves, is going to start at 1, 1, or it starts at that point 0, 1, and it's going to end here. So it's going to pass through this point, pass through that point, and pass through this point, and this is how it's going to look like. So that will be our graph. So this is all at the end of this video. Then other videos, you can search them on YouTube on trigonometry. You're going to find all the solutions for the tutorial sheets and other things on trigonometry. See you in the next session.